not, you will be lost. Okay. This is how we look at a single slit. For a single slit here, we still actually get an interference pattern. There's some length L here. What actually happens here is as the light, monochromatic incoherence, comes through the slit opening, we actually zoom. If we imagine like a near infinite number of lines coming through here, we actually end up getting a change in path length here, depending on where that light is going. This is our delta L. And because of that, some of the light, such as a line up here and a line down here, could interfere constructively or destructively. And then this would match up with this one, and then the one beneath it would match up with the one beneath it. So we get this kind of pattern. What it turns out to be is an easy equation, one that we already are familiar with. D sine theta equals m lambda with two changes. This is a big D because that is how wide the slit opening is, and this is actually for a dark fringe this time. If you want a bright fringe, what you'll have to do is d sine theta equals m plus 1/2 lambda. And these are for bright fringes. The dark fringes are for m equals 1, 2, 3, 4. You get that idea. For the bright fringes, m equals 1, 2, 3, 4. But there's also an m equals 0 special case. At m equals 0, you still have a bright point, but it doesn't really follow those equations the way I've kind of written them. The reason being is that for a single slit, if this is an intensity graph or how bright the light is, boink, 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 boink. This right here is a wavelength difference, and then this is two wavelength difference, because those are my dark points, which means that at these points right here, this is like negative 3/2 wavelength difference, and this is a positive 3/2 wavelength difference. But at the half wavelength point and at the negative half wavelength point, you don't have a bright fringe, you don't have a bright peak. You're still within the central maxima. So because you're still in this central maxima, we kind of just start looking at the bright fringes later on. It also means that because in this case, this bright maxima, it's actually bounded by the minima. The minima here actually become a little bit more important to think about when you're looking for the width of this bright fringe. So if I kind of redraw this picture up here,